Uvicorn is that it is asynchronous, the alternative being synchronous one, WSGI, and the course does emphasize asynchronous communication. It's becoming increasingly standard for Python applications to use ASGI. It's quite fast, Uvicorn. It's built on the UV loop and HTTP tools C libraries. It handles real-time communication with WebSockets as well as other methods of communication. The WebSocket is the one that we are using for Flet, and it's production ready. It's used by FastAPI, Starlette, and Flet. FastAPI and Starlette are open source applications. Uvicorn is widely used, so it's not a Uvicorn itself. It's not a toy or a learning application. It's widely used in deployment by the big names, right? Google, IBM, finance, Capital One, professional services, right? Insurance. So if the application needs a high concurrency, asynchronous communications, a very skilled application, they are using Uvicorn. We're building a very small application, but the tool is highly scalable. We are not building a scalable application. We are just using Uvicorn because it's simple. In the way that we are using it, we simply start Uvicorn and pass it the host, the port, and the place for the application to run. So you get a very superficial introduction to Uvicorn, but you are using it, and you can dig in deeper on your own. So in our application, the front end is a UI layer. We're using Flutter Web as the renderer. It takes place in the background when you use Flet. You have to have Flutter installed on your development computer. The transport layer is a real-time link using WebSockets plus HTTP. Because it's real-time, it won't work on the free tier of LeapCell. We do have it deployed to fly.io for this real-time link. The backend, right now, the app and the state is currently stored in the Flet application. There is no connection right now to the database, although you could connect it from your Flet Python application to the database, SQLite or PostgreSQL, which we cover in the next course, or external APIs such as OpenAI for LLM communication, which we also do cover. There's many other places such as OpenRouter for the LLMs, or Llama, or other things. So once you have this structure, it's super flexible, and you can build whatever you want once you start understanding the concepts and break it out. So this piece is the one that we are focused on. This is where all the action is happening. You do need the communication layer. You do need the front end. We're trying not to bog you down because you could really spend a lot of time on the front end, and I think the interviews and everything else is probably going to focus on the concepts for the back end, unless you're applying for a design job. In our application, the user opens up a browser. So the user of your site or customer, Chrome, Firefox, Safari, one of these browsers. Then they're going to connect to the server. Our server is at a specific endpoint. So in our project here, we call it our URL here at the top, Jesse-async-project. And this is how you would access it, .fly.dev. You can also put it to a custom URL, although I don't think it's necessary, but you could. We have done it as well too. So this is a real person. You should change the name to your real name. Then Flet will render the UI in a browser. You just saw it. It's using Flutter on the back end or behind the scenes. The user interaction, so a button press, is sent to the Python backend. Flet will send a signal to the Python backend, and it will start processing it on the backend. It'll send the signal back to the front end. It's a visual representation. Your customer clicks on your web page, there's a communication back and forth in real time with the backend server that we have running on fly.io runtime. And this Uvicorn, the asynchronous gateway interface, will have the application logic here, as well as the application state, which we're using a Python dictionary for. We're not using the database and external APIs yet, but you can easily connect it to something like an LLM or a database with this structure.